Hello, everybody, and welcome to the last lecture of the semester about food and drugs. So this is why we even had to bother learning organic chemistry, is so that we can talk about the chemicals that make up the foods and the drugs that we ingest. So let's get started. All right, so we've already been talking about at least this basic food stuff already. We learned back in the fossil fuels and alternative fuels lecture series that you can make biodiesel just from fat. You can make it from corn oil. And so now that you've had a little bit more organic chemistry under your belts, now you can possibly start to see that this long bit here, this is what we call a hydrocarbon chain. And then this bit here is an ester functional group. And then this is a bit more hydrocarbon stuff, okay? So we call this a triglyceride because if you were to break each of these ester linkages, then you would be left with glycerol, and that's part of the biodiesel manufacturing process, and then it yields these fatty acid chains, these hydrocarbon chains, but then they turn from esters into just carboxylic acids. So each of these would be a fatty acid, but now that they are linked to this glycerol molecule, we call the entire conglomerate thing a triglyceride. Okay, so we've got that. So the main thing that I want you to take away from this slide is that fats are made of a glycerol backbone and then a fatty acid chain here. One thing that I'd also like to highlight here is that you might see some of these double bonds, okay? And then down here on this chain, there are no double bonds whatsoever. Okay, so the presence or absence of double bonds, we learned that having a double bond can lead to a degree of unsaturation. This is the exact same kind of unsaturation that we're talking about when we talk about saturated fats versus unsaturated fats. Saturated fats tend to be fats that are solids at room temperature, whereas unsaturated fats tend to be liquids at room temperature. Okay, so an example of saturated fats would include the thicker components of coconut oil, but also just like animal fats. But then these unsaturated fats that would have these double bonds, those would be mostly like vegetable oils. Okay, and so you've probably heard that some are better for your heart than others. Now, one thing that we sometimes talk about is the presence of a cis or a trans double bond, and that's when you get trans fatty acids. I'm not going to talk about that this time. All that I would like you to think about for this semester is that if you've got a saturated fat, it's a solid at room temperature and it has no double bonds whatsoever. If it's unsaturated, then it'll start being a liquid at room temperature, and it's unsaturated because it has these double bonds between carbons in the carbon chain. Okay, all right, let's move on. So here are some more basic foodstuffs. So this first one is an amino acid. We talked about it a little bit, all right? So it's an amino acid because we've got this carboxylic acid functional group here, and then off to the side we also have that NH2 group, the amine group. So since we've got both the carboxylic acid and the amine group, we just called the whole thing an amino acid. Now, if you take quite a few amino acids and you link them together to make those amide bonds that we talked about in the functional group lecture, the very first organic chemistry lecture, then you start making what we call a peptide chain, which is the primary structure of proteins. All right? So a protein is basically a polymer of amino acids, which would be the monomers. Okay, so amino acids are the monomer unit. A protein or a peptide chain would be a polymer of many amino acids that have all been bound together through this amide bond. Okay, so that's proteins. Now let's talk about sugars. So glucose is one of the simplest sugars that we know of, well, that exist in nature. Glucose is not table sugar. Table sugar is actually sucrose. We'll talk about sucrose on the next slide. But you can see also that this basic sugar is another monomer unit for something that would be a much longer polymer. Okay, so starch, we know that starch is a carbohydrate. We also know that sugars tend to fall into carbohydrate, the carbohydrate group as well. But so within the overall group of carbohydrates, there are long chain polymer carbohydrates like starches, and then there are these monomers like glucose. Okay, so again, glucose is a monomer that can make up a longer polymer like starch. Okay, so that's another big important note. I don't know if you've noticed, but I keep on coming back to this new theme here of this is the monomer, this is the polymer. Okay, so you've got this monomer-polymer relationship, both in terms of carbohydrates versus, simple carbohydrates versus complex carbohydrates. And then you've got the same thing going on between single amino acids and proteins. All right, so branching off of sugars and carbohydrates and such, here are some sweeteners. Okay, so we've heard about fructose before. Fructose has a slightly different structure. We're not going to really worry about it, but you can see that it's got a similar carbohydrate structure, but this one is linear as opposed to glucose, which forms this like ring structure that has an oxygen there in the middle, so it's got like this ether as part of its ring structure, and fructose doesn't really have that. Fructose also has an interesting ketone deal going on here that we don't have over here in glucose. Now here's sucrose. This is good old-fashioned table sugar, okay? So sucrose is actually a dimer, not a monomer, not a polymer, it's a dimer. So it's a dimer of a glucose molecule and a fructose molecule. I know that I just said that fructose has this ketone thing going on here, but it can actually slightly get rid of it by going through a small chemical reaction in order to make this 5-carbon, this 5-membered ring. It's not a 5-carbon ring, it's a 5-membered ring. Okay, so again, sucrose is a dimer of glucose and fructose together. Some other sweeteners that you might have encountered include glycerin, which is actually the same exact thing as glycerol that we talked about as part of the biodiesel making process. It's also the same glycerol that we saw as the backbone on triglycerides or fats. So that's kind of interesting. You keep on seeing similar structures pop up in nature. Huh. If you take away one of these entire like carbon and alcohol groups, then you come up with ethylene glycol, which is also a sweetener. And then you start seeing things like aspartame and sucralose. And it's a little bit tough for us to see why aspartame would taste sweet. But what I want to highlight here is the fact that sucrose and sucralose, don't they look almost exactly the same as each other? So now take a couple of seconds and figure out if you can pick out where the differences are, right? Because if one is sucrose and one is sucralose, they've got to actually be different molecules. So what's different between them? Of course, we had to have a Blue's Clues moment in this lecture. That's right. It's these two chlorines, right? So sucrose has all alcohol functional groups coming off of the carbons like that, whereas sucralose, 2 of them are replaced by chlorines. So that's interesting. That's how you get Splenda. Alrighty, let's also talk about olestra, which olestra is a little bit outdated now. I think that the last time that I found anything that had olestra in it, I was in high school, so that was a really long time ago now. And I doubt that you can find any foods that actually contain olestra. But Olestra was a fat replacement, so it still behaved like a fat, and it still it had virtually no taste, so it was almost like a vegetable oil. But it was a low calorie fat replacement compound that your body would not be able to digest in any sort of way. And so it was really attractive for diet foods and low calorie foods. And it was most commonly used in potato chips, like low calorie potato chips. And so you can see that it had the same taste and mouthfeel as a fat, but it was too large to be absorbed. So it still had, these long chain fatty acid groups coming off of it, but instead of having this central backbone of glycerol, which lends to a certain structure that your body is used to handling, it had sucrose as the structure there in the middle, as you can see. So as a result, it was a completely different shape, and the human body didn't know what to do with it, and so it would not be absorbed by your metabolism at all. And so you would eat it, and it would just go through your digestive system all the way out the bottom, and it would come out your bottom like a little fatty, gross bit of Olestra. Yeah. It led to a problem that we refer to as anal leakage. Isn't that disgusting? And so that is actually why Olestra is no longer preferred in any sort of food, is because people don't want to experience any sort of gross anal leakage. I know I don't. Anyway, so that's a fun chemistry sort of thing to think about, isn't it? That concludes our lecture video on food chemistry. If this was interesting to you, maybe take some additional classes with us in chemistry or maybe over in the nutrition department. For now, why don't you take a quick break, maybe have a snack, try to think about what organic chemicals you're ingesting in that snack. And then I'll see you at our final lecture video, which is going to be on prescription and recreational drugs. I'll see you over there. Which, by the way, Molly also falls into the ecstasy category. So MDMA um, is the well, slightly more official chemical name or chemical abbreviation that encompasses both ecstasy and Molly. They both contain MDMA. Ecstasy is typically taken in a pressed pill form, and it has some other things cut with it, such as cocaine and ketamine, and sometimes meth and caffeine as well. And Molly is typically given in powder form, but sometimes you have like those little capsule powders. But again, Molly is also cut with coke, meth, caffeine, and other things. So either way, whether we're talking about ecstasy or Molly, it's still all MDMA. I have heard anecdotally, you guys, I've never taken ecstasy or Molly in my life. I've heard that somehow they hit differently. Maybe, I don't know, maybe you guys would know better. I don't know. But it's all still MDMA.